So what is a function? A function is just some x, which is your input, some relation, and then y. And this is the important part. It has a unique output. So what that means is for every x, there must only be one thing that you can output. Now, there's several ways to write a function. The first one we're going to talk about is how to numerically write a function. So numerically, if you have a point 3, 4 and another point 6, 4, this would be a function because for every x value, there is a unique y value. Now, it's okay that y has appeared twice. This is fine. You can have two outputs of the same thing, but for something to not be a function would look where you would have 3, 4 as a point, and then again 3, negative 2, because what this is saying is your input is 3 and you have two outputs. That is not a function. Algebraically, they can look like y is equal to x, y is equal to the square root of x, but more commonly we write them as f of x is equal to x squared, where the f of x takes on the role of y, the f indicating that this is a function. Now, my non-example would be x squared plus y squared is equal to 4. This is a circle, and the circle is definitely not a function. Now, how do I know that's not a function? Well, because if I know what the graph looks like, the graph of a function could be a line. The graph of a function could also be a parabola. But again, if I want to look at what a non-example is that circle. This is not a function. And I know that because if I draw a circle, what you see if you draw a vertical line test is that the vertical line will touch the graph in two places, and that is an indication that for one x you have two outputs of y, and that's an example of not a function. So when we're looking at functions, it's really important for us to remember the notation. So f of x is equal to y. What this means when I write this is the number inside here is the x value, the input, and the output is y. So if I'm looking at the first piece I have, f of 1, or the function value at 1, where 1 is my input is 1, my output here is negative 3. Now, the next one, this indicates that my function is called g. The name and the letter on the outside just gives us a different value to look at. So this is saying g of 4. So my x value is 4. My output this time here is 0. Now, if I'm telling you this is saying f of x is equal to 2. That means that output is 2, which means my y value is 2. So I come over and look at the graph. Where is f of x? This is underneath f of x. F of x is equal to 2. What is my matching x value? My matching x value in this case is 4. I do the same thing with the next one, and again, this tells me my y value is 2, but this time I'm looking underneath g of x because my function this time is called g of x, so I come underneath g of x, which gives me my y value is 2, so therefore my x value must be 1. Now, let's say I give you the function as an algebraic statement where I have f of x is equal to 3x plus 2, and I want you to find f of 4 and f of x plus